So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacture hype? Then tune in to the Weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.
Welcome to this week's Energy Show. Now today, we're going to solve the data center power shortage problem. And at the same time, we're going to solve the electricity affordability crisis, and we're going to find billions of dollars to solve both problems at once. And here's how. Right now, utilities want to provide power to data centers at big markups. New distant power plants need to be built. Then long-distance transmission lines need to be constructed to get that power to local data centers. It takes 5 to 10 years for the new generation and power lines to be constructed. In the meantime, electric rates for homeowners and businesses skyrocket. Now, there's a faster, cheaper, more reliable way to power data centers. We can add extra solar and battery capacity on rooftops of homes, businesses, and public buildings. This will take 1 to 2 years instead of the 5 to 10 years for new solar and battery installations at distant power plants. Much cheaper power, since there's no need for the expensive long-distance transmission lines. Data centers can help offset costs for these new rooftop solar and battery systems. The electricity costs won't go up. It could even go down with all that extra local generation. So let's examine the details. Problem number one, rapidly increasing electric rates. Now, this chart shows the historic California residential rates going up fast. This data comes from the California Public Utilities Commission. These rates have gone up about 8 to 10% per year through 2030. This chart shows more accurate rates for California homeowners. This data comes from the Energy Information Administration. What we did is we factored out rates for apartments and subsidized customers who typically have much lower baseline rates. The result are homeowner rates. Now, historically, these homeowner rates, single-family homes, have gone up historically 3% a year before 2014. Then rates went up 6% a year from 2015 to 2019. Then they went up 12% per year from 2020 to 2024. We expect that rates will continue to increase from 2025 to 2030 because of all this extra build out and the extra demand for electricity, especially data centers. Now, going back once again, according to the Energy Information Administration, national rates are starting to increase as fast as California's. It's insane. Homeowners are getting crushed with high bills. One analysis recently showed that past due balances to utilities went up by 9.7% over the last year. Energy affordability is now a key political issue. Problem number two, power demand is increasing. Data centers are the biggest contributor to this. They're being built rapidly, but they need a lot of power to operate. So electricity demand in the U.S. is expected to go up at 3.5% per year. Now, this graph shows the historical increases in electricity demand from 1950 to 2024, and then projections through 2040. Fast increases, as we kind of talked about earlier about California, fast increases started around 2024. These power demand increases are mostly from data centers. Demand was flat for the prior 20 years, basically because of energy efficiency. We used LED lighting. We had better building efficiency, better insulations, more efficient appliances. So that kept demand flat. But now utilities are embarking on a rapid investment pace to meet these new power demands from data centers, but from other factors I'll show you in a minute. But don't forget, utilities get a guaranteed 10% rate of return on their net assets for all these new power systems. So they are compelled to improve their profits for stockholders. So the bigger and faster the investments happen, the faster they generate profits. And, candidly, the executives get bonuses and the stockholders do better. So this pie chart shows in more detail the source of future electricity demand growth. The total is 160 gigawatts over the next 5 years. And the gigawatt is 1,000 megawatts. It's huge. A typical power plant is about 500 megawatts, or about half a gigawatt to maybe up a gigawatt. So that's like probably 200 or 300 more power plants. That's a lot. Now, of this demand, 55% is expected to come from data centers. 20% is expected to come from new industrial and manufacturing buildings. 10% is for oil and gas mining, and 20% is for everything else. And these are expected growth rates that are compiled from a number of different sources, most important of which are the utilities. And candidly, I'm skeptical about utility load growth projections, since they make more money by building more infrastructure. And if they can convince everybody that they need more power and more infrastructure, they get to build it. So they're always going to be on the optimistic side of the demand for electricity, so that they can just build those assets. Nevertheless, there's no doubt that there'll be substantial increases in power demand. Problem number 3. Utilities cannot provide these power demands rapidly or affordably. Utilities take 5 to 10 years to expand their power delivery to data centers. It takes 2 years, only 2 years, to build the data center building. The chips are already on order. So it's pretty fast, especially, maybe not in California, but especially in places where the permitting is relatively easy. So only a couple years. But if they want to power that data center with a natural gas system, there's a delay of 7 years to get new gas turbines, and a long time to actually build that pipeline. But when you look at actually when the power plant is built, 10 years to build the long distance transmission lines from a distant power plant, regardless of the power source. So whether it's a solar farm in the desert, whether it's a new geothermal system, or it's a nuclear plant that's far away from society, it's far away. And it takes 10 years, takes a decade to build the power lines from that new power source to the urban areas that it's needed. Yeah, that's 10 years for transmission lines. But look at some of the other generating capabilities. 20 years to build a new nuclear power plant. And the last plant was built in the U.S. was over 20 years, a Vogtle plant, and it cost over $20 billion. Utilities are very reluctant to invest in new nuclear power plants because it's going to take forever and it's going to be expensive. Now, that's nuclear fission. Nuclear fusion, which is when you fuse two hydrogen atoms together, that's what the sun is powered from. Building local fusion plants, I don't know what they're smoking. There are no fusion plants that exist right now. We're still at the very early stages. And the newest fusion power plants are finally getting them to where they're able to generate a little bit of power. They're able to generate about as much power as a flaring match. And that's with a huge power plant. So 30, 40 years away from anything that's really going to take off from nuclear fusion. And that's if everything goes well. Now, you compare all those time frames, 7 years of gas turbines, 10 years for transmission, 20 years for nuclear power plants. Compare that to 1 or 2 years for rooftop solar and storage. Way faster. Now, but you got to remember, as I mentioned before, utilities will charge existing customers, existing ratepayers, for new poles and wires that they put in. And you got to remember, the data centers don't pay a penny until they're actually operating and buying the power. So in the meantime, where does all that money come from? Well, the utilities try to raise rates in advance. That's what's happening to us right now. So all ratepayers are going to pay more for new long-distance transmission lines and power plants for these data centers. Data center infrastructure build-out is the main cause of today's skyrocketing electric rates, and it's not going to change. I mean, they're trying to figure out how to pay for this. They're trying to figure out who's going to advance all the money. A big, big fight. As I mentioned, there's a way better way. So that's just kind of talking about where we're at right now. The current plan is to provide all new power for these data centers through kind of our conventional method of generating and transmitting power. It requires new large-scale power plants, whether it's solar in the desert or hundreds of miles away, or nuclear, whatever. And since these power plants are always built far away, expensive transmission lines, which will take 10 years. So there's a simple solution. Install all that new power capacity on rooftops combined with batteries. Every sunny rooftop should be covered with solar panels. Every building should have battery backup systems, and these batteries can also buffer that power so it's available in the evening. You don't need any new poles and wires. You don't need any new massive power plants. All of this new power from rooftop solar and batteries goes directly onto the local distribution grid. That's the lower voltage grid that's powered all the buildings. So all these data centers are basically connected to the local distribution grid. So if we add power to the local distribution grid with mini power plants on top of every building, makes a lot of sense. Now, the data center owners and operators, they're desperate to build those data centers and turn them on. They have money and they could contribute costs for the rapid build out of local rooftop solar and battery systems. Homes and businesses with new solar and battery systems will benefit from those power costs. So in addition to pushing out power to these data centers, these homes and businesses can have lower electric rates. And all this can be done without increasing everybody's electric rates, because this power would go on top of rooftops and batteries, and the data center owners and operators could contribute. And bottom line, data centers get new incremental power much cheaper and faster than if they contracted through utilities. There's lots of different ways to arrange these payments among the host customers, the homes and businesses, the utilities, and the data centers who really need that power fast. One way to arrange these payments is to set a goal, an arbitrary goal for now, that 50% of the local demand growth that's caused by the data center build out must be supplied and generated from local rooftop solar and batteries. Utilities would provide the other 50% of power through their normal mechanisms. The host customers, that's the homes and businesses, in exchange, they'd get a 20-year retail net metering agreement on all new systems. With that 20-year cash flow, they can easily get financing. There may be other ways of financing these things, but it works out really, really elegantly. Net metering is super simple. The data centers would partially reimburse the utilities for net metering payouts, because the utilities are going to have to spend money to buy that power back. And the data centers are going to have to figure out some arrangement to do that. That's fair. And look at the benefits here. The data centers get much faster power availability, like in a period of 1 to 2 years, not 5 to 10. And it's going to be cheaper power. Utilities would continue to build the infrastructure and get reimbursed for half of all that build out. And the homeowners and the businesses would be able to get much cheaper electricity because they now have rooftop solar and batteries. It solves the extremely fast growing affordability problem for homeowners. Electricity rates are going through the roof all over the country. And this is just the beginning of a very bad cycle that's going to happen. So remember, when you're looking at all that power demand that's needed, there's a tremendous amount of uncertainty about future demand growth. Candidly, I think utilities exaggerate it, but maybe they're right. Who knows? But since we're really going to get more information as the AI build out continues, we see how AI is used. Let's build that new data center capacity really fast with rooftop solar and storage and sending that power through the distribution grid. But we can do it incrementally and affordably by using rooftop solar and storage. Bottom line, instead of a few new large power plants in every city with expensive poles and wires, put in hundreds or thousands of local rooftop solar and battery systems. You don't need any new technology. It works. It's able to be constructed very, very quickly. The batteries are terrific. No permitting or bureaucratic delays. I mean, heck, we're turning around a rooftop solar power plant with batteries in a matter of weeks here in California. Faster, cheaper, and more reliable to use local power from rooftops for data centers than to have utilities go through a 10-year process to build distant power plants and transmission lines. Finally, and most importantly, I would love to hear your feedback on how we can make this plan work for homeowners, businesses, data centers, and utilities. That's all the time we have on this week's Energy Show. Thanks to all of our listeners for tuning in. And if you missed any of today's show, you can go to our website at energyshow.biz and listen to the podcasts.
Thanks for tuning in to this week's Energy Show.